Hello children, welcome to my channel. Mole, mole, mole. As many times we hear the term. एक बार में तो लगता है समझ में आ गया, दूसरे बार लगता है कि सब बिगड़ गया. ऐसा नहीं है. Actually, mole concept you have to study the theory part. You have to do the practice of the numerical part very minutely and very carefully. So let us try and solve one or two problems of mole. The cost of table salt NaCl and table sugar C12H22O11 is rupees 2 per kg. Rupees 2 per kg is the cost of NaCl and rupees 6 per kg for C12H22O11. It's rupees 6 per kg. Okay. Calculate the cost of their per mole. So what is the cost of per mole of NaCl and per mole of table sugar, that is C12H22O11. So as per the data we can see that cost of NaCl is equal to rupee 2 per 1000 gram. Because it's per kg. So our work will be first to find out that 1 mole, MOL actually is written for mole. If you want you can write MOL or you can write MOLE, but as a symbol MOL. 1 mole of NaCl is actually equivalent to how many gram of NaCl? Sodium का atomic mass 23 plus 35.5 for Cl. This many gram, which comes out to be 58.5 gram. It comes out to be 58.5 gram. So this is the data. The cost of 1000 gram of NaCl is rupee 2. So we'll find out, therefore, cost of 1 mole, that is 58.5 gram of NaCl will be equal to how much? Rupee 2 for 1000. So 2 by 1000, that gives the cost for 1000 gram. It is rupees 2. You are doing unitary method. Then later on what you have to do, multiply by 58.5, right? So this is for 1 gram and this is for 58.5 gram. So this will be the cost, this many rupees. If you calculate it, it comes out to be, by a calculator I have done, but remember in exam you have to do it manually only, 0.117. That is the cost of 1 mole of NaCl, that is equivalent to 58.5 gram of NaCl. Since I have solved for NaCl, I think you can solve it out for C12H22O11. For that you have to find out again what is the mass of 1 mole of C12H22O11. How are you supposed to do that? See, atomic mass of carbon will be 12. So 12 into 12 plus again hydrogen is 1. So it is 1 into 22, or you can directly write 22, plus oxygen is 16. So 16 into 11, it comes out to be 342 gram. This will come out to be 342 gram. So you can proceed by the similar procedure. चलिए दूसरा न्यूमेरिकल देखते हैं. Calculate the number of moles in 7.85 gram of iron. This is given in gram. The mass is given in gram. Next is given in mg of silicon, and the third one is given mu g of carbon. So the units of the mass that is given, they are different. So what formula are we going to apply? We know, suppose the first one we are telling. So moles of iron, if we are calculating, we are finding what will happen. Number of mole will be equal to mass of iron divided by the atomic mass of iron. So this is applicable for all other elements. Why? Because atomic mass of iron, if you consider it exactly 55.8, or you can take it 56 also during your exam if you think so. So if it is given 7.85 is the mass of iron divided by say 55.8, the exact one I am taking. So this 55.8, it's the atomic mass of iron. So this should be equivalent to 1 mole of iron. So how many moles are present in 7.85 gram of it? So it becomes 7.85 by 55.8. Now here again for silicon it is given in mg. So we need to convert it to gram. Why? See 4.68 mg of silicon. So when we convert it, so mass of silicon becomes 4.68 into 10 to the power of minus 3. Divided by, you can take it 28 or 28.1, the atomic mass of silicon. And what happens for carbon? Again, this is given in mu g. So if it is given in mu g, we'll consider it 65.6, convert it to gram, 10 to the power of minus 6 divided by, for one atom, or divided by the atomic mass of carbon, which is equal to 12. So 65.6 into 10 to the power of 6, converting it to gram by 12. Now this is a very common question for all exam. Calculate the number of atoms in. One is given in moles, 52 moles of argon. I think this is very easy. First one, 52 mole of argon. We know that 1 mole of anything. So I will say 1 mole of argon will contain 6.022 into 10 to the power of 23 atoms of argon, of course. So I am writing atoms. Therefore, 52 mole corresponds to how much? We all can do it. Second one. Now here in 52 U of helium and 52 gram of helium, children confuse here. Please keep in mind that U goes for unified mass. It is atomic mass unit. So as per the atomic mass unit, mass of a single helium atom is actually equal to 4U. So if I know that it is of a single helium atom, then 52U corresponds to how many atoms? And I think we all can do this. Now, third one, 52 gram of helium. Keep in mind that 4 gram of helium corresponds to the molar mass of it. So if this is the molar mass of it, obviously 4 gram will contain again 6.022 into 10 to the power of 23, this many atoms in it, because it corresponds to 1 mole. Therefore, 52 gram corresponds to how many atoms? So though the calculations are left, I think the process is quite clear to you, and please do the calculation and complete it. These terms we already know, atomic mass, molecular mass, yet I think few points we need to recall, like AMU we have said, atomic mass unit, and it is represented by small u. Actually, 1 U is considered to be the unified mass. This is equal to 1/12 the mass of a C12 atom, and 1 U expressed in kg is equal to 1.6605 into 10 to the power of minus 27 in kg. Now the question arises, why only C12 isotope? Why an atom, the mass of an atom of C12, the isotope of carbon? Because this isotope is considered to be very stable, can be obtained in abundant and easy to measure accurately. Like, we often take the mass of an atom of hydrogen as 1.008 because it is actually 1.008 times heavier than the 1/12 the mass of C12 isotope. So mass of a hydrogen atom is considered to be 1.008 U. After the atomic mass unit, we'll see the molecular mass, which is also expressed in U. In a molecule, we have atoms. So, sum of the atomic masses of all the atoms in a molecule. So, that will be equivalent to the molecular mass. So, molecular mass will be equal to summation of atomic mass of each atom into the number of atoms present. That is what is seen here. Each atom means here hydrogen is there, here oxygen is there. So 2 into the atomic mass of hydrogen 1.008, 1 into the atomic mass of oxygen, that is 16. So it comes out to be this as exact 18.016 U. Now relative atomic mass of an element is its comparison, that is the average mass of its atoms compared to 1/12 the mass of C12 atom. Now the exact mass of C12 atom is taken as 12U. Since it is relative, it's unitless. Yet when we use its value for practicality purpose in numericals and all, we are allowed to use it in terms of atomic mass unit, that is U. So this is how it actually is represented, average mass of an atom, of an element by 1/12 the mass of C12 atom. Now actually it accounts for all natural isotopes of an element. There are many elements that exist in nature in various isotopic forms, but its abundance in nature vary. So it is also the weighted average based on the abundance of each isotope. We have H, we have Cl. So we can see carbon also, we are seeing C12 and C14 are there. So it is applicable for all the elements that have isotopic forms.